Hey friends, so we are back into geometry, and this has been a really weird chapter. It's taken a long time, and that's because we've had fall break, we've had encounter, we've had days out of school, and so this chapter has taken us a really long time. So before we move on into chapter 1, section 6, which is our next section, I wanted to just do a quick overview of what we've learned so far in Chapter 1, just as a reminder, so that it's very clear what you need to have known to this point, and what's going to be expected of you on your upcoming test. We only have 2 more sections to go, and we're going to review the chapter really quickly by taking a look at our haiku page. Okay, so follow along with me as I come over here. Okay, here's our Chapter 1 haiku page. I'm going to slide this over so that you can see the whole thing. Okay, there we go. This is what it looks like for me. These are all our chapters that are upcoming. And you have our assignment right there, our list of practice problems, and we're just going to go back through. Remember, Chapter 1, Section 1 was on patterns and inductive reasoning. We talked about patterns and drew some things, drew some patterns. We learned about conjectures. Chapter 1, Section 2 was on points, lines, and planes. We defined some of those things. We also defined a segment. We defined things like a midpoint. And that continued into the next session called Segment and Their Measure, where we actually learned different ways to measure the lengths of segments and how do we talk about segments, different ways to notate segments. Remember, if you talk about the difference between the length and the distance, this says distance between points A and B, and this says the length of segment AB. So there's just a little bit difference in the notation. At the end of that section, we introduced the Pythagorean theorem. We talked about how the distance formula actually comes from that Pythagorean theorem. And then we introduced angles. We talked about how do I notate angles, how do we talk about them, how do we name them, how do we classify them. And then lastly, we looked at segment and angle bisectors. And if you remember, a bisector is something that perfectly divides something else in half into 2 equal parts. So I can divide a segment into 2 equal parts. I can divide an angle into 2 equal parts. And both of those things are called segment and angle bisectors. That is a review really quickly. Obviously, that was very fast of what we have done so far in Chapter 1. And if you remember, the purpose of this chapter is really just to introduce the language behind what we will be using all year long in every single chapter in geometry, really. So this is really a chapter that is no different than our L2 class, where we're just introducing language and visuals behind how we're going to talk about some of the things in geometry. And you did this assignment last, and this is a really good assignment to tell you what you need to be able to do on your upcoming test in terms of recognizing patterns, using the distance formula to find the distance between two points, naming angles and measuring angles, using the angle addition postulate. And here, this is a great problem, number 7, being able to do all of this. Plot points, sketch an angle, classify the angle as right, acute, obtuse, or straight. Well, that's spelled incorrectly. I'll have to fix that. Writing the coordinates of points, interior points, exterior points, finding the distance between those 2 points, all of that stuff. And then being able to do a problem like this. This is a great assignment to give you an idea of what you're going to need to be able to do on your upcoming test. So that was a very long-winded way to just kind of remind you to re-enter your brain into what we're doing, why we're here, as we only have a couple more sections left in this chapter. And in fact, this next section, 1.6, is titled, if you want to title this, it is titled, and I'll type it so that I don't have to write all of this. It is titled Vertical Angles and Linear Pairs. And you don't know what either of those things are right now, but that's the point of this lesson, is to introduce those to you. So we are going to introduce a lot of vocabulary today. So if you do not have your definition sheet handy with you, you need to get it out now so that you can add to it, because we're going to add a lot to our definition sheet today. So this lesson is in 2 parts, and to finish the first part, all we're going to do is just introduce a few terms to you. Okay, so the first thing you need to know, the first thing you need to add to your definition sheet is complementary angles. Okay, complementary angles. And complementary angles are 2 angles whose sum is 90. What do I mean by that? Here's what I mean. 2 angles, so that let's say I have angle A and angle B. complementary angles are two angles so that when I add them together, their measures equal 90 degrees. So this actually doesn't make sense because remember, when we're talking about the measure of an angle, we need to add this little m. That implies I'm talking about the actual value of the angle. If I talk about angle A and angle B, I'm more talking about their shape, their structure, how it looks, less about the actual value behind the angle. So two angles whose sum is 90. So when I take two angles, call them A and B, I add them together and they are 90. That is complementary angles. Now, what A and can be, there's no limits on what A and B can be. For example, angle A could be 89 degrees and angle B could be 1 degree. 89 plus 1 is 90, so those would be complementary. There's no restrictions on what A and B can be, right? So these would be complementary angles. Angle A could also be, let's see, 45 degrees, and that would make angle B 45 degrees, and thus these would be congruent angles. But complementary angles don't say that they're congruent. All they say is that when I add them together, they equal 90. So any two values that I could add together, any two angles that I could add together, maybe it's 63 and, let's see here, 27. Those would be two complementary angles because when I add them together, they equal 90. In the same way, supplementary angles are two angles whose sum is 180 degrees. So make sure you add both of these to your definition sheet. If you need to pause the video because I'm going too fast to get them down, do it, but I'm just going to keep right on going. So let's say now instead of two angles A and B, let's say I have two angles C and D. And the measure of angle C plus the measure of angle D equals 180, then those two angles, we would call them supplementary. Okay. Now there's no restriction on what the relationship of these angles what these angles could be. For example, this angle could be over here. Maybe this is angle C. And this angle could be over here. And this is angle D. All that makes, they don't have to be touching, they can be adjacent, but they don't have to be. All that must be true is that when I add the measure of these two angles together, they equal 180. That's what makes them supplementary. Okay, so once again, I'm not going to go into exactly what angle C and D could be because I think I made that point up here. But C and D can be any values as long as when I add them together, they equal 180. Once again, I could have 179 and 1. Those two angles, because they add to 180, would be supplementary. Okay, so that's complementary angles, that's supplementary angles. This is the written definition of those two things. We're going to need these. We're going to need these definitions moving forward. Okay, two more terms, and then we'll pause and move into the next video. Vertical angles. Okay, vertical angles are one of the most important concepts in all of geometry. We will use this concept all year, so you really need to make sure that you get this. Okay, so I'm going to define vertical angles first. Okay, and you can write this in your notes, but this also needs to go on your definition sheet. Vertical angles are the pairs of opposite angles formed by two intersecting lines. Okay, the pairs of opposite angles that are formed by two intersecting lines. So right here, what we have is we have two intersecting lines, and let's add to this picture. I'm going to add points. Okay, and then I'm going to name all of these points. This is going to be A, this is going to be B, C, D, and E. Okay, and here's what happens. When two lines intersect, they form two pairs of opposite angles. What do opposite angles mean? It means there are two angles that are pointing in the exact opposite direction. So angle BEA right here is pointing this way, and angle CED is pointing this way. So those are two opposite angles. So we would say angle BEA and angle CED are vertical angles because they are a pair of opposite angles. Okay, but that's not all. Do you see another pair of opposite angles formed by this picture? I hope the answer to that question is yes. There's one angle pointing this way and another pointing this way. So we could also say, and I'm just going to write it underneath here, that angle BEC and angle AED are also vertical angles. Okay, so the pairs of opposite angles formed by intersecting lines are called vertical angles. Okay, they're called vertical angles. Why are they called vertical angles? Don't exactly ask me why. I think the idea is that they are just know that they're exactly opposite of each other. Okay, and then there's one important rule that you need to know about vertical angles, and this is the most important thing about vertical angles. In fact, it is one of the most important theorems. If you look at your theorem sheet, this will be one of the first theorems on that theorem sheet, and that's this. Vertical angles are congruent. Vertical angles are congruent. So why do vertical angles matter? Why is it something that we even need to label? Because we know that because angle BEA and angle CED are vertical angles, that means that they are congruent. So we could also write congruency statements. Angle BEA is congruent to angle CED. And we could do the same for angle BEC and angle AED, but we're not going to. Okay, so vertical angles are congruent. So it tells us a lot. We know a lot about this picture right now. If we were going to add tick marks to this picture, or excuse me, arc marks to demonstrate what angles are congruent, we would add them like this. BEA and CED would each need to have one arc mark that indicates that that one arc mark that they're congruent. And since these angles are congruent, but it's a very different angle, we give it its own set of arc marks. So we give it 2 arc marks. Okay? So, just knowing that 2 angles are vertical can tell us a lot. Now, our last idea of vocabulary before we will move into the second video is something called a linear pair. Okay? And a linear pair, I'm going to define this, and you can put this on your definition sheet. I would also write it in my notes. A linear pair is a pair of adjacent angles that are supplementary. Now, if you recall from just a couple slides ago, what does it mean that 2 angles are supplementary? I'm going to write it under here just to remind you. It means that their sum is 180. Sum is 180. And the only difference between a linear pair and just 2 supplementary angles is that here we are stipulating that in order for it to make a linear pair, they have to be adjacent, meaning they have to share a side. They have to share that side right there to make them a linear pair. Okay, so what we would say here is the sum of the measures of the angles that form a linear pair is 180. So I'm going to write out specific to this example. We would say that angle AOC and angle COB, when I add them together, and remember this is measure because we're talking about the number value, I should have included that there, is 180. Okay, so that is a linear pair. 2 adjacent angles that are supplementary, whose sum is 180 degrees. Okay. That's all the vocabulary that we're going to introduce in this section. The second video is all practicing these definitions. All it is we're going to take some examples that I'm going to give you and practice them together. Okay? So make sure you get this all down on your definition sheet. Make sure you kind of understand these concepts loosely, and then watch the next video for some practice.